Assalamualaikum warahmatullahi wabarakatuh. Honorable Judge and distinguished guests, on this occasion, we are proud to present an extraordinary innovation born from our past. Ladies and gentlemen, did you know that Indonesia is home to the Bajo people, a community that live and settle in the middle of the sea? Due to their settlement in the vast ocean, the Bajo people generally live with limitation, one of which is electricity for their daily needs. As a result, the community faced low health standard. 90% of the children unable to read or write and lack development of infrastructure. One of the Baju settlement that serve as our case study is Tanelandu village in the central Butuan Regency, Southern Sulawesi province. Ladies and gentlemen, the problem we mentioned above inspired us to create an innovation that we call Portable Combined Renewable Energy, aka POCREN, a device that combines three renewable energy converter into one unit. This device is made from environmentally friendly material suitable for use on open beaches and capable of generating large amount of energy. This innovation was developed by our leader Abdulaziz and me as the member of the team Isnu Rizaldi from Padang State Polytechnic under the supervisor or Dr. Rosita Sumiati. The design of Cochrane was carried out through four main phases. As outlined in this slide, in the identification of energy needs and potential in Tanilandu, we conducted data collection through literature studies and obtained data from National Statistic Agency. From this data, we concluded that the total electricity demand for Tanilandu village is approximately 175 kilowatt. We also gathered data from the Ministry of Maritime Affairs regarding the potential of marine resources in Indonesia, which show an average sea current velocity, air velocity, and sunlight intensity as you can see in the slide. This data on energy needs and potential become the basis for determining the dimensions of converter component we will create. Thus, the total energy generated by three energy converter is 252.2 kilowatt. Below are the details of the Cochrane components along with exploded view. To answer that this device can be realized, we simulated the chassis Cochrane using a prototype smaller than the actual size. The weight distribution of each prototype component was calculated and we found four primary load points of the chassis. One for the wind turbine, two for the solar panel, three for the wheel, and four for the panel box. The simulation result showed that the maximum von Mises stress is still far below the yield strength of AC stainless steel 316L. And for the largest displacement, the panel box had a displacement value of 0.131 millimeter. Next, in calculating the energy requirement, we found that the electricity produced exceed the energy demand with a surplus percentage of 44.2%.
The next point to be discussed is the SDGs element. One, providing clean energy to the Bojo community in Talandu village. Two, the use of bamboo composite as the primary material for manufacturing tidal and wind turbines. Three, revitalizing and enhancing the existing industrial sector in Central Buton. Next, the sustainable impact of use. Cochrane are as follow. One, reliability energy supply. Two, reduction of environmental pollution. Three, improvement in quality of life. The Cochrane system generates electric from solar panel, wind turbines, and ocean current turbines. Solar panel convert sunlight into DC power, which is regulated by a solar charger controller and stored in battery. Wind and ocean turbine produce electric from kinetic energy, managed by a wind controller. Allow power flow to a voltmeter for real-time monitoring. When need stored DC power is converted into AC by an inverter for artificial use.
That's all about our presentation innovation. Thank you for your attention.